couple of times. I'd like to take some time and just clarify it for you. So question 5, question 6, and question 7 are all very, very similar. They're asking you to determine an angle, or they're asking you to determine 2 angles, or they're asking you to determine 1 angle. And they always tell you where they want the answer to be from. It's called a restricted domain. And with this one, they want to make sure that their answer, so whatever answer you give them, they want to make sure that your answer is only between 0 and 90 degrees. In other words, if we're thinking about the Cartesian plane, we're only thinking about quadrant 1 there, right? This one, they're asking for 2 angles, okay? And they're allowing our answers to open up a little bit. And they're saying we can give them answers anywhere between 0 and 360 now. So that's all the way around, right? On the, if we're talking about, that's all 4 quadrants being accepted here. And down here, they want it only, an angle, sorry, only between 90 and 180. So they're wanting our answer only to be in quadrant, well, between 90 and quadrant 2. So this one's only quadrant 2. So this one's quadrant 1. They only want answers for them. This one would be all 4 quadrants. And this one is only quadrant 2 that they want answers from. So if I get an answer that's not in quadrant 1, I'm not supposed to give it for this question. And if I get an answer that's in quadrant 2, that's not in quadrant 2, sorry, I'm not supposed to give it for this one. And this one, I need to make sure that my answers take into account answers that could be in any of the 4 quadrants. So a little bit of a difference there. Let's take a look at one of these questions here. Let's take a look at this one. Let's take a look at sine of 0.29. So if I was going to do that question, we're going to add a little page here, and we'll put it here. And so if I'm going to solve for this, the question's actually saying solve for theta. And it wants to know what value, if I put in for sine, I'm going to get 0.29 out, so the side length ratio. Well, the very first and easiest way to do this is to get an answer is to use your calculator. So if I use my calculator, I'm going to do sine inverse of 0.29, and I'm going to get an answer of approximately 17 degrees. So that gave me an answer that's right here. So that answer would be right there, okay? And you notice that we can check my answer. I can check it simply by doing take sine of 17, and we should get pretty close to 0.29. So it worked. That was one of my answers. And if I was doing question 5, where they only want answers between 0 and 90, then that would be a fine answer. My answer is in between 0 and 90, and I would be good to go. Now, what if I happen to use this exact, here it is right here. What if that exact same question was number 6 though? And they allowed me to have answers that took into all 4 quadrants into my answer solution. So if I'm allowed to go beyond quadrant 1 in my answers, then I'm going to think to myself, well, where else is sine theta positive? And that comes directly because I'm looking right here and I'm noticing that it's sine theta equals positive 0.29. So if we remember the CAST rule says that it's going to be CAST, which means that sine is going to be positive in quadrant 2 as well. So there's going to be another answer. Well, where else is sine positive? The answer is in quadrant 2. So sine is positive in quadrant 1 and quadrant 2. but we have my answer in quadrant 1 already. I'm wondering what my answer is in quadrant 2. Well, we make use of the related acute angle, which means that that would be 17. And then we calculate the other rotational angle, which in this case would be theta would equal 180 minus 17. So in this case, it would be 180 minus 17, and I would get 163. So that, let's do a check. Is it true? If I put sine of 163, do I get 0.29? So 163 sine, and I do get 0.29, so it worked. Now the only problem is that this answer's in quadrant 2. So that's okay as long as I'm allowed to have my answers in quadrant 2. So if this was question 6, and if I was talking about find all the answers on all 4 quadrants such that when I put them into sine, I get 0.29, then I would have to put in both answers. So my answers are 17 degrees and 163 degrees on, if I'm going to take theta, between 0 and 360 degrees on all 4 quadrants. Now, if they only want, if I go back to question 5, and they tell me that I'm only supposed to go between 0 and 90, then the only answer is 17 degrees, because this one's too big. It's outside of the quadrant. So for question 5, this would be the only answer. I shouldn't be giving 163 because that's outside what they wanted me to calculate the answer to. Okay, so let's do another one. Let's just see how this works. So let's take number 6. So number 6, I'm going to pick one of these. I don't know. Why don't I pick cosine of 0.4? 0.42. So let's add another page. And let's do this one. And let's say that my answers can be anywhere between 0 and 360 degrees, okay? So it can be anywhere in the 4 quadrants. So here you go. There's your 4 quadrants. And according to the cast rule, cosine's going to be positive down here. Cosine's going to be positive over here. Sine is positive, so cosine is negative here, and cosine is negative here. So CAST. So my 2 answers that I'm looking for with this one, where cosine is positive, is going to be, there's going to be an answer here, and there's going to be an answer down here. Okay, that's where my 2 answers are going to come from. Now, how do I get my answers? Well, the easiest one to get is using your calculator. So 1, use calculator. And what we're going to do is cosine inverse of 0.42, and we're going to come up with 65 degrees apparently. So theta equals 65 degrees, so this is 65 degrees. So we know that our other answer is going to be down here in quadrant 4, and the related acute angle goes here. So my rotational angle to get there is going to be that angle. This will be my second angle. So what I'm going to use is I'm going to use cast to get my second angle. And I notice that it's going to be 360 would be all the way around. So if I went all the way around to here, that would be 360. I'm not quite going that far. I'm taking 65 off. So I think I'm going to get 295 will be my other angle. So theta 2 is going to be 295. And what that means is that my answers on this domain will be theta equals 65 degrees and 295 degrees. And what that means is that cos of 65 will equal 0.42 and cos of 295 will equal 0.42. And so that gives me 2 answers for that. Now, there you go. That's kind of interesting. If I go up and take a look at another question, let's pick, oh, I don't know. I like this one here. Let's try this one. So let's add another page. And so now what I'm going to do, and let's put it on a domain of 0 to 360. So we're going to take all the answers between 0 and 360. We're going to notice that I want my answer, I want to know where sine is negative in this one. So my answers are going to have a negative sign. So if I think about that a little bit and do for my Cartesian, I know it's going to be C-A-S-T. So I know that sine is going to be positive in here. I know that sine is going to be positive in here. So where I want to be is here and here. And my angles are going to be this one and this one. So that's kind of interesting. So let's do this. Number one, we're going to use our calculator. And so we're going to do sine inverse of a negative this time. So 0.373 negative, second function sine, and I come up with theta equals negative 21.9, or approximately negative 22 degrees. Now, negative 22 degrees, that's awesome. That's this answer. That is going to be negative 22 degrees. Okay? And now, that's great, and that's definitely an answer, and that's how I get there. But let me ask you a question. Is negative 22 degrees on this domain? Is negative 22 between 0 and 360 positive? It's not. So even though that's an answer, it's not in the format of the answer that we want. This says that my answers must be positive. Now, this is still a good answer. I just can't call it negative 22. I need to call it 360 minus 22. So we're going to make this a positive rotational angle by doing 360 minus 22, and that's going to be 338 degrees. Now, that's not a different answer. This is the same answer. It's very important that we understand this. We used our calculator to get negative 22. And that is one of my answers. The only thing is I can't write it like a negative because they told me that they want all my answers positive. So I'm not finding this other angle. What I've just done is changed this from being negative 22 to talking about it as positive 338. And that'll be one of my answers. And let's do a check to make sure. So we're going to sine of 338 equals, and it equals pretty close to what I needed, negative 0.37. Now it's a little bit higher, but that's because we did some rounding and what have you, but it's pretty close. So now we have to go back and get our second answer. Like I said, we've got this one. And it was originally named negatively, and we changed its name to be 338. We now have to go after the other answer. That's the other answer. And to do that, we're going to know that this has a rotational angle in here of 22 degrees, because this angle and this angle are both related acute angles, which means that my other rotational angle will be all the way around to there. So that'll be 180 plus 22. So use cast. And the other angle, the other solution is 180 degrees plus 22, which is 202 degrees. So when we go to give our final answer to this, we're going to say the solutions to sine theta equals negative 0.373 negative on 0 to 360. So all my answers have to be positive on 0 to 360 are, my first answer is 338 degrees, and my second answer is 202 degrees. And please remember that this negative 22 and this positive 338 are the same answer, just written differently. But 202 and 338 are different answers, definitely. One's in quadrant 4 and the other one's in quadrant 3. Okay, that's pretty cool. I think that's probably enough for me. I'd like you to finish off questions 5, 6, and 7 tonight for homework, and we'll move on from there tomorrow.